Chapter 5, Section 8 is about absolute value graphs. Okay, an absolute value function, if you remember, absolute value is those two bars on either side that means distance away from 0. So the equation for that function is always going to be y, or f of x, is equal to the absolute value of x. This is your parent function. The graph is going to look like a V. It will open either up or down. So it will either look like this or this. Okay, now a translation is when you move that graph either horizontally, vertically, or both. So your graph ends up in a new location. All right, that's what we're going to work on in this section. Graphing and moving, translating. So below, how are these two graphs related? The first one, right here, is just our parent function. Y is equal to the absolute value of x. Notice how it starts here at 0, 0, and just goes up 1 over 1, either direction, forever. Okay, the second one, still the same V shape, still up 1 over 1, but this time it starts down here at -2. If you notice, it was -2 and this starts at -2, so all that happened is it was translated or slid down 2 places. All right, so how is this graph at the right related to the parent function? If you remember, the parent function would start at 0 and would go up 1 over 1, like this, both directions. The graph that's actually on here still has that same up 1 over 1 slope on both sides, but this time it starts up here at 4, positive 4, which means they actually took that parent function and they added 4. Okay, so we slid up 4 units. Okay, that's the answer to this. What are the domain and range? Remember that domain is x, range is y. So if I'm looking at my domain values, everything is covered. Since the arrows are pointing as if this continues on forever, that means every x value is covered. So your x's, or your domains, are all real numbers, which you can actually write out, or this symbol, that's an R, it means all real numbers. Your range values, or your y values, because the arrows go on forever, everything from the starting point on will count, but nothing less than 4 will work since the graph actually starts at 4. So everything from 4, everything greater than 4 will be a range value. Okay, what is the graph of the absolute value of x plus 2? Anytime you see this, you know that we have the V with the slope of up 1 over 1 on both sides. Because this 2 is added on at the end, I'm going to do that same graph, but I'm going to start it here at 2. Okay, that's what that's going to look like. What is the graph of y equals absolute value of x minus 7? Okay, so we have our V shape at -7. So we start here at -7, and it goes this way. Okay. How do these graphs below compare to our parent function? If I'm adding k, because it's adding, that means up. So this actually moves up k units. Whatever number is there is how far you'll move up. Because this one is subtracting, that means that I move down that many units. Okay, adding on the outside of the absolute value bars moves it up. Subtracting on the outside of the absolute value bars moves it down. All right, that's all that we're going to talk about today. Actually, nope, we're going to do one more. Let's do one more thing. Writing an equation now that we know that. Okay, so 11 units up from this parent function. Because it says up means I'm going to add. 14 units down, because it says down, means I'm going to subtract. So if they ask us for a translation of y equals absolute value of x, that's where I'm going to start. Then it tells me 8 units up, so I'm going to add 8. Okay, same if I'm moving it down, I start with my parent function. Because it says down, I subtract. Okay, now that's all we're gonna do for part 1. Your assignment that you should be able to do with just what we talked about is on page 345, numbers 6 through 20, and then numbers 1 and 2 on your lesson quiz.